On this video, I would like to go over comparing decimals, comparing decimal numbers. And it might not be as straightforward as whole numbers, but it's also not as confusing as fractions. So by comparing, we mean knowing which decimal is bigger. So for example, if I have a 0.09 and if I have a 0.3, which of these decimals are bigger? And one way to do this is to change them both to fractions. So remember, when you're changing to fraction, you write this number in the numerator. So the 9 is in the numerator, the 3 is in the numerator here. And the denominator, this is going to be 1 followed by 2 zeros. There are two numbers after the decimal point. So 9 over 100. Over here, we have one number after the decimal point. So it's just going to be 1 0. And when we're comparing fractions, we need to have the same denominator. Right? So we need to multiply both top and bottom here by tens, and we'll get 30 over 100. So now that we have the same denominator, which one is bigger, 9 over 100 or 30 over 100? And we can ignore the denominator when you're comparing since they're the same. And this one has the bigger numerator, so that means that this fraction, this fraction is bigger. Now, you don't really need to change decimals to fractions to compare, but before I tell you the method of comparing decimals, I'd like to tell you one rule with decimals, and that rule is you can attach or detach a 0 to the end of decimals. So what does that mean? So that means if I have, to the end of decimals, if I have a 0.1, I can just simply attach a 0 here. So 0.1 is actually the same as 0.10. And 0.10 is the same as 0.100. You can just add zeros at the end. You can't do that with whole numbers. You can't just add a 0 to a 1 and make it into a 10. 1 does not equal 10, right? But you can do that with decimals. And you'll see why. Because once you start to change these to fractions, you'll see that this becomes 1/10. This becomes 10 over 100. This becomes 100 over 1000. And if you reduce these fractions, they're all going to be 1/10. So when you're adding a 0 to the end of a decimal, you're basically, in terms of fractions, you're basically multiplying by 10 to both the numerator and the denominator. So you're not changing the value of that number. Okay, so that means we can change 0.2 to a 0.20. We can change 0.3 to a 0.300. We can change 0.5 to a 0.50. And we can also detach. We can also detach zeros from the end of decimals. So if you have a really long decimal number with a lot of zeros at the end, you can just ignore all these zeros at the end of the decimal point. So 0.340000 is the same thing. It's exactly the same thing as 0.34. But you do need to be careful of where the 0 is. If the 0 is in the middle like this, so the 0 is not the last number here. There's a 3 after the 0. In this case, you can't just erase the 0. Okay, this does not equal 0.3. So you can only erase zeros that are at the end. Since all these zeros are at the end, that's why you could erase these zeros. But let's say if you have a 0.001, you can't you can't just remove the zeros because there's a 1 at the end. There's a 1 at the end. You can't remove these zeros, so these are not the same. But if you have a 0.100, then you can remove the zeros. Oops, I should use a different notation than what I did on the left. So you can just cancel these zeros like this, and becomes 0.1. This is okay. This is not okay. So the difference was that the zeros are at the end here, are at the end. Here the zeros are not at the end. Oops, not at the end. Okay, so remembering this rule for decimals, let's go back and compare these two decimal numbers here. Okay, so this one has two numbers. This one, after the decimal point, that is. This one has only one number after the decimal point, and it's always easier to compare if they have the same numbers, so the same number of digits after the decimal point. Okay, so since we can't really change this one, or we can't make this into a 1, remember we can't erase zeros when they're not at the end. You can't just subtract the 0. But we can add a 0 here. We can add a 0 here. So now we're comparing between 0.09 and 0.30. And now it's much easier to see which decimal is bigger. Is it 0.9 or is it 30? And now this, thinking of whole numbers, this is like comparing 9 and 30. So, I mean, of course, 30 is bigger. But that wasn't so easy to see when we just had 0.09 and 0.3. But now since we've changed them to have the same number of digits, it's much easier to see which one is bigger. Okay, so let's try another example. Yep. All right. Which one is bigger, 0.1 or 0.07? 0.1 or 0.07. Okay. Again, this has 1 digit. This one has 2 digits. So let's change them all to 2 digits. Let's change this one so that it becomes 10. Now we have 2 digits here. And then this one is just 0.07. Now, which one's bigger, 0.10 or 0.07? This one is like a 10. It's like comparing a 10 and a 7 here. So we can say that this one is bigger. Okay. Another general rule when you're comparing decimals, 0.3 and 0.289, which one is bigger? Always compare from the left. That's the rule for any numbers, really. Because the more we go to the left, remember the place values we had. Let's say we have a number like this. Oops. The farther we go to the left, the bigger the place value becomes. So this one is bigger than this one is bigger than this one, bigger than this one, and it becomes smaller as we go to the right. So we want to compare the biggest place value first. Okay, so let's compare from the left. So this one is 0.3. This one is 0.2. It starts with a 2 here. Okay, so because the 3 is already bigger than the 2, we don't even need to worry about the other digits here. Right? So this one is automatically bigger than this one. Okay. How about 0.17 and 0.168? Which one is bigger here? Okay, again, using the same rule, we compare from the left. The leftmost number is a 1, so they're the same in this case. So then we go on to the next digit. So we compare 7 and 6. Which one is bigger, 7 or 6? Well, 7 is bigger than 6. So we don't need to compare the next digit now because we've already concluded that 7 is bigger than 6. So this one would be bigger. Okay, let's try one last question. One last comparison here. Let me actually clear the whole board. So we have 0.238 and 0.216. Which one would be bigger? Actually, 0.32. Let's try this one. Okay, which one is bigger? Let's use both methods that we've learned, or the two main methods that we've learned. So one way to do this is to make them all have the same number of digits. So 0.238 has 3 digits. So we make the 0.32 to have 3 digits by attaching a 0 here. So now we can see that we're comparing 238 and 320. In which case we can say that 320 is bigger. Or we can use the other way of comparing from the left, 0.238, 0.320. We compare from the left. The leftmost digit is a 2 here. The leftmost digit is a 3 here. So 3 is bigger than, there shouldn't be a 0 here. So 3 is bigger than 2, so that means 0.32 is the bigger number. Okay, so that's how you compare decimal numbers. Now I almost forgot to go over this, but we have mixed decimals. How do you compare mixed decimals? So let's say we have 1.097, and let's say we have a 0.869 or 8674. Which one of these two numbers are bigger? Okay, so the rule is they seem to have the same number of digits here, right? But they have different values. So because this one has a whole number, but this one doesn't, right? So in this case, it's much easier to compare from the left. If you line up the two decimals so that the place values line up, a good way to do that is to line up the decimal point. You can just see that this is missing a whole number. Okay, so since the top number, this number has a whole number while this one doesn't, we can say that this one is bigger. Because this doesn't have a whole number, it means there's a 0 in place of the whole number. Okay, so again, comparing from the left, we see that for the leftmost digit, this number is bigger. Okay, so that's why we don't even need to compare the other numbers here. Okay, we just start from the left and we compare them towards the right. Let's try one more. 3.489 and 1.9864. Okay, we compare from the left. Compare from the left. And another way to do this is to separate the whole numbers from the decimal. So let's actually make that into an 11. So separating this into the whole number part and the decimal part simplifies things. So compare from the left again, compare the whole number part. 11 is bigger than 3, right? So when we're comparing from the left, this is already bigger with the whole number. So we can just conclude that this one is bigger. Okay, so when there's a mixed decimal, I think it's easiest if you just separate them into whole number and decimal. Compare the whole number part first, and then if they're the same, only if they're the same, compare the decimal parts. But if they're not the same, the number with the bigger whole number part is the bigger number.